Okay, in this video we're going to talk about types of energy and heat transfer. The essential standard that matches this video is 1.13. Explain how the sun produces energy which is transferred to the earth by radiation. So there are three I can statements. I can differentiate between nuclear fusion and nuclear fission. I can identify the forms of energy produced by the sun. And I can compare and contrast how energy is transferred. So the sun is composed of hydrogen and helium, which is held together by extreme forces of gravity. Nuclear fusion, particles come together or fuse to create energy. This is found on the sun and from our stars. Nuclear fission is when particles split to create energy, and this is typically what happens with our nuclear reactors when they split atoms. So that's basically what Homer's job was on The Simpsons. Heat transfer. Sources of heat for our planet, or the main source of heat for our planet, is the sun. Heat is transferred by one of three methods. These should be familiar to you, but we're going to review them. Conduction, convection, and radiation. Okay, transfer of heat from one molecule to another within a substance is conduction. Temperature is a measure of the average kinetic energy or the speed of a molecule in a substance. So it's going to depend on the material used if it's a good conductor of heat or not. So something that's metal would be a good conductor of heat. Something that like sugar would not be a good conductor of heat. So if I took a stick pin and I lit it, the energy from the lighter is going to transfer, or the heat is going to transfer to the stick pin, and the particles are going to move very fast within the stick pin, causing it to warm up. Then we have convection. Convection is the transfer of heat through the movement of a fluid like water or air. This is what typically causes warm air to rise and cold air to sink. Then we have radiation. It's the transfer of heat from the sun through space by the electromagnetic spectrum, which is a range of electromagnetic waves arranged by wavelength and by frequency. So if you look at my diagram here, we have wavelength, and this is the measurement, or the symbol for wavelength, and it's measured in meters. So then we also have down here frequency, which is measured in hertz, and this is the symbol for frequency. So you notice we have a range from gamma all the way to radio waves. So gamma rays have a wavelength of 10 to the negative 12th, and they have a frequency of 10 to the 20th. And you see how the waves are very close together here. X-rays have a wavelength of 10 to the negative 10th and a frequency of 10 to the 18th. Ultraviolet or UV rays have a frequency of 10 to the 16th and a wavelength of 10 to the negative 8th. Visible light, this is known as our rainbow Roy G. Biv. So that has a wavelength of 10 to the negative 6. And then for our frequency, it's getting closer to 10 to the 12th. Our infrared waves, 10 to the minus 5 power for our wavelength, 10 to the 8 for the frequency, 10 to the second power for the microwave rays, whereas the frequency is 10 to the 6th. Radio waves are just 10, and then they have a frequency of 10 to the 4th. So if you notice, they're kind of the opposite. The shorter the waves, the greater the frequency. The longer the waves, the lower the frequency. So now what I want you to do is complete the electromagnetic spectrum handout. You're going to need to go to this website right here. You can also use this website as a reference for your electromagnetic spectrum graphic organizer projects. Good luck.